Hello and welcome to this recording, which will look at a particular technique that can be used for forecasting when preparing budgets. The technique that we're going to look at is moving averages. The definition of a budget is that it is a quantitative statement for a defined period of time, which may include planned revenues, expenses, assets, liabilities and cash flows. The period of time that a budget relates to will be in the future. A budget will provide a focus for the organisation. It will aid the coordination of activities within the organisation and it facilitates planning. For most businesses, sales is the principal budgetary factor, and therefore the sales budget will be the first budget to be prepared. Organisations need to ensure that they make what their customers are willing to buy. Once they've prepared their sales budget, then they can go on and produce further budgets such as a production budget, various cost budgets and the cash budget. Now, since budgeting is looking to the future, an organisation needs to forecast what they think will happen in the future. They will use historic data for this. Historic data is data from the past, so they can use past sales figures to help them to determine what the sales are likely to be in the future. Now you will come across the term time series. Time series is basically a term used to refer to a series of data over a time period. So if you have the sales figures for the last 12 months, then that is a time series. If you have the wages paid over the last 6 months, that is a time series. So it's any series of data over a period of time. Now, to use that data to forecast, we need to ensure that we have sufficient data. So many of the questions that we look at will only have a small amount of data. But in reality, we should be looking at as much data as possible to use that to forecast over the next 12 months. So if we have a look at what the components are of a time series, so we're going to be using our time series to forecast. We will be looking to see if we can identify a trend. So does the trend indicate that over the period of time there is an increase in the data or a decrease in the data? We will also be looking to see if there are any seasonal variations. These are changes in the data caused by seasonality of the business. There are also cyclical variations, and these are slow-moving variations that can be caused by economic cycles or social trends, and they're generally long-term. However, since we're predicting only over the short term, we're going to ignore these. There are also random variations. These are unpredictable fluctuations in the data. And since we can't predict the unpredictable, we're also going to ignore these. So we're really going to be concentrating on trying to identify any trend in our data. We're going to look to identify seasonal variations in the data and then we can use those to forecast into the future for our budget preparation. The way in which we identify a trend is by calculating moving averages. And we'll look at how that is done in just a minute. We will also then look at calculating the seasonal variation. There are two methods of doing this. There is the additive model, where the seasonal variation is calculated by deducting the trend from the actual data. So the seasonal variation is equal to A minus T. Alternatively, we can use the multiplicative model, where the seasonal variation is the actual data divided by the trend. Right, so bearing that in mind, let's have a look at an example. So here we have a shop that has the following sales over a 5-day trading week. So in week 1, Monday to Friday, we've been given the sales figures. In week 2, Monday to Friday, we have again been given the sales figures. Now if we look at these figures, we can see that in week 1 they have increased each day. Then they drop again at the start of week 2 and start increasing again. So we are seeing increase in data, a drop, another increase in data. So we're looking to identify what the overall trend is across that 2-week period. Is it a general increase or is it a general decrease? We're then also going to look and see if there are any seasonal variations. So the method is to firstly rewrite all of your data in one long column. So I've already done this in preparation. So these are the actual sales figures, Monday, Tuesday, Wednesday, Thursday, Friday, and then week 2, Monday, Tuesday, Wednesday, Thursday, Friday. So I've got one column of data. I'm then going to calculate what is known as the moving total. Now, moving total is a total of the data over a time period. Now the time period I'm going to choose is 5 days. So I'm actually going to work out what's called a 5-day moving total. So it's a 5-day moving total. The reason I've chosen 5 is because the data has been presented in groups of 5. So Monday to Friday is 5 days. Then Monday to Friday, another 5 days. So I'm taking a 5-day moving total. When you calculate these, many questions will tell you what time period to use. The smaller the time period, the more pieces of data you will calculate. Always go for an odd numbered time period. And do look and see if there is any obvious time period that you can select. So to calculate a 5-day moving total, we take the first 5 days of sales. So that is Monday through to Friday. And we add those 5 pieces of data together. And it comes to 75. So that's our moving total. Now we write it against the midpoint of our 5 days. So between Monday and Friday, the middle day is Wednesday. So we've written it against the Wednesday. We now want the moving average. This is also a 5-day moving average. And we calculate that by taking the moving total and dividing by 5. So that gives us 15. Now our next moving total. We now start with Tuesday and we take 5 days. So that will be Tuesday, Wednesday, Thursday, Friday, plus the following Monday. We add those 5 pieces of data together and it comes to 77. And again, we write it in the midpoint. So the midpoint between Tuesday and Monday is Thursday. The moving average is 77 divided by 5. That gives us 15.4. And that is how we continue. So the next moving total is starting from Wednesday. So we've got Wednesday, Thursday, Friday, Monday and Tuesday. Add them together, comes to 79, divide by 5, gives us 15.8. Then we take Thursday to the following Wednesday. Add those together, 81. Divide by 5, 16.2. The next moving total is starting with Friday, and we'll add up Friday, Monday, Tuesday, Wednesday and Thursday. That comes to 83. Divide it by 5, 16.6. And lastly, Monday through to Friday. Add those together, comes to 87. Divide by 5, 17.4. And that is where we stop, because we have not got enough data left to do another 5-day moving total. So we have our moving total, we have our moving average. The moving average is the trend. So we now have calculated our trend. And if we look at that trend, we can see that there is a general increase. Now we're trying to forecast. So what we need to do is use that trend to forecast into the future. So we need to be able to continue this trend on into the future. The way in which we do that is to calculate the average increment in the trend. And there is a formula for that. We take the last trend figure minus the first trend figure, and we divide by the number of trend figures minus 1. So the last trend figure is 17.4. The first trend figure is 15. The number of trend figures we have is 6. And we take away 1. That gives us 0.48. that is the average increment in the trend. So how do we use that? This is telling us that on average the trend increases by 0.48 for each time period. So in this example, for each day. So we have to assume that that will continue. So on that basis, the trend figure for Thursday will be the trend figure for Wednesday plus 0.48. Our trend figure for Friday, 17.88 plus another 0.48. And as we're looking to forecast, if we wanted to forecast for the following Monday, then we can calculate that our trend for the Monday would be the last trend figure, 18.36 plus 0.48, 18.84. So we have now forecast the trend in our sales for Monday of week 3. So that's the future. Our trend is 18.84. Now this is not at the moment the sales figure that we expect to make on Monday. It is the trend in the sales. We need now to look and see if there are any seasonal variations. And if there are, we apply those seasonal variations. As I've already mentioned, there are two models. There is the additive and the multiplicative. We'll start with the additive model. So this is the additive. And to calculate the seasonal variation, it's the actual sales minus the trend. So if I do a different colour, so we go to our first trend figure, which is 15. So the actual sales, 15 minus 15, 0. That's not a different colour. Then we've got 18 minus 15.4, 20 minus 15.8, 12 minus 16.2, 14 minus 16.6, and the last one, 17 minus 17.4. Let's highlight these. We don't use these last figures that I've calculated here because remember these are forecasts. So they are not going to come into our seasonal variation calculation. So that's our seasonal variation using the additive model. If we were to use the multiplicative model, Then we do A divided by T, actual divided by trend. 15 divided by 15, 0. 18 divided by 15.4 is 1.17, and so we continue dividing the sales by the trend. Oops. So if I just highlight these are our seasonal variations using the multiplicative model. What we need is one seasonal variation for each time period. So let's just now concentrate on the additive model. So on Wednesday, the seasonal variation is 0. We've got a seasonal variation for Thursday, we have one for Friday, one for Monday, one for Tuesday, and one for Wednesday again. So at the moment, we have one seasonal variation for each day, apart from Wednesday, when we have 2 seasonal variations. Where this is the case, and the more data you work with, the more likely it is that you will have several seasonal variations for a time period. You need to average those seasonal variations. So if we now just look at how we do that. So if we look at this table here, this has averaged the seasonal variations. So we have a column for each time period and in total. So we've got a column for Monday, Tuesday, Wednesday, Thursday, Friday. We've written into this table our seasonal variations. So on the first Wednesday, we just go back to our workings. So on the first Wednesday, we had a seasonal variation of 0. And then these were our seasonal variations for Thursday, Friday, Monday, Tuesday, Wednesday. So here's our seasonal variations. That's the one we calculated Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday. Because we want to average our seasonal variations, if we look at Monday, we only have 1, so the average is minus 4.2. Tuesday, there is only 1 variation, so the average is minus 2.6. Wednesday, we've got 2, so we add them together and divide by 2 to get an average. Thursday is 2.6, Friday is 4.2. Now our seasonal variations should add up to 0. At the moment, if we add them across, it comes to minus 0.2. So we're going to make an adjustment and make them add up to 0. Because it's minus 0.2, we need to add 0.2 to get it to come to 0. Now how you choose to add that 0.2 is entirely up to you. It is such a small number, it will make very little difference as to how you add that 0.2. Here you can see we've added it to Monday and to Tuesday. We could have added it to Monday and Friday. We could have divided 0.2 by 5 and added a little to each day of the week. It really does not matter. We are talking about very, very small figures. We're also using averages and we're using moving averages, so the accuracy is fairly low in what we're doing. So here we chose to add it just to Monday and Tuesday. So minus 4.2 plus 0.1 minus 4.1. Minus 2.6 plus 0.1, the seasonal variation is now minus 2.5. The others have not changed, and if we add them all together, it now comes to 0. So there's our seasonal variations. How we use that seasonal variation, we will now look at. So if we go back to our calculations, Monday I had forecast a trend of 18.84. We now know that for Monday, the seasonal variation, if we just go back to the table, minus 4.1. And when we originally calculated our seasonal variations, we did actual minus trend. What we're now trying to find out is what we expect the actual sales to be for Monday. So if we were to rearrange this, actual is equal to the seasonal variation plus the trend. So we know that the trend for Monday, 18.84, seasonal variation, minus 4.1, add them together, and we have 14.74. And that is our forecasted sales for Monday of week 3. So now, what about if we were using the multiplicative model? We calculated the seasonal variations, A divided by T, and we have these 6 figures. So again, on the Wednesday, we have 2 seasonal variations. We need 1 seasonal variation for each time period. So in this example, 1 seasonal variation for each day of the week. So we do similar to as we did earlier. So let's go back to the data. So here we have a table with the multiplicative seasonal variations written into it. So same layout, column for each time period. So our first seasonal variation for Wednesday was 1. For Thursday, 1.17, Friday, 1.27, the following week, Monday, Tuesday, Wednesday. Again, we average them. So because there is only 1 for Monday, that is the average. The same for Tuesday. Wednesday, add them together and divide by 2. Thursday and Friday. Now if we add them across and get a total, you'll see it comes to 5.01. Now this is where it differs to the additive model. Instead of adding up to 0, it needs to add up to the number of time periods. Now we have 5 time periods: Monday, Tuesday, Wednesday, Thursday, Friday. So our seasonal variation needs to add up to 5. At the moment it adds up to 5.01. So we just need to reduce the seasonal variations by 0.01. Again, entirely up to you how you do that. It's such a small figure. In this example, we've just taken it off the largest seasonal variation. Right, I can't emphasize enough, it really does not matter how you make that total come to 5. Take it off 1 seasonal variation, take it off 2 seasonal variations, take it off all 5 of them, entirely up to you. So we have taken it off Friday. So that's changed Friday's seasonal variation to 1.26. The others have stayed the same, and when we add them all together now it comes to 5. So how do we use this seasonal variation? Because it is multiplicative rather than additive. Well, we were forecasting for Monday, so the seasonal variation using this model is 0.74. So let's go back to our workings. So Monday trend is 18.84. The seasonal variation for Monday is 0.74. Now thinking about how we calculated this seasonal variation, we did A divided by T. So rearranging that, A is equal to S times T. So our actual sales forecasted for Monday of week 3 is the trend multiplied by the seasonal variation, and we get 13.94. So that is our forecast for Monday. You'll see we have 2 different results. So 2 different forecasts depending on which model we use. Generally, the multiplicative model is more accurate. However, when you're working with these, you will generally be told which method to use. So that brings us to the end